Hey guys, so today we're going to calculate the rate of change. So let's go to question number 3C. It says, at what rate does the temperature change per hour between 6 a.m. and 10 a.m.? Show your work. So let's talk about the definition of rate of change first. It's the rate of change is the rate at which the dependent variable changes in relationship to or in relation to the independent variable. What does that mean? Let's look at our graph. Our dependent variable is temperature, and our independent variable is time of day. So if I want to find the rate at which the temperature changes over time, that would be the rate of change. I would have to figure out how the rate at which the dependent variable, the temperature, is changing in relationship or in relation to the independent variable, which is the time. So to do that, you might be familiar with a bunch of equations related to rate of change. For instance, rate of change is actually equal to slope. So if I were to find the slope from this area to this area, that would be the rate of change, rate at which the value is changing. You might be familiar with y2 minus y1 divided by x2 minus x1. That also works as an equation for rate of change. But when it comes to specifically in science, the y value, change in y value divided by the change in x value doesn't always work because your dependent and independent variables may not necessarily be exactly on the y-axis or exactly on the x-axis. Well, so what you really should rely on is this. It should be the final minus initial dependent value, in this case final minus initial temperature, divided by the final minus initial independent value, in this case the final minus initial time of the day. That should give you the change in temperature on the top divided by the change in time in the bottom, and that should give you the change in temperature per hour. So this question is asking, at what rate does the temperature change per hour between 6 a.m. and 10 a.m.? Let's use this equation, and please write this down in your notes as well. So, to find the rate at which the temperature changes per hour, temperature is my dependent variable, it should go on the top, and the time is my independent variable, it should go on the bottom. So, let's start with the top. I should have my final temperature minus initial temperature between 6 a.m. and 10 a.m. So, 6 a.m. and 10 a.m. is here. My final temperature at 10 a.m. is 40 degrees Fahrenheit. My initial temperature at 6 a.m. is 30 degrees Fahrenheit. So, I'm going to do 40 minus 30, which should give me 10 degrees Fahrenheit. That should go in my numerator. Next, I need my denominator, which is final minus initial independent variable, which is time. So my final time is 10 a.m. minus my initial time is 6 a.m. That gives me 4 hours since I'm asking for the temperature change per hour. So that's what I'm trying to see, how many hours has passed. So now that I have my change in temperature from the top and my change in time for the bottom, I can just plug it into the equation. The rate of change should be the change in temperature, which is 10 degrees Fahrenheit, divided by the change in time, which is 4 hours. And that gives me a rate of change of 2.5 degrees Fahrenheit per hour, meaning that every single hour between 6 a.m. and 10 a.m., my temperature is changing by 2.5 degrees Fahrenheit with every hour. And your rate of change can be different in different parts of the graph. Another thing, before we move on, if your rate of change is a positive number, that means your temperature or your dependent variable is increasing in value. That's why we got a positive number. But if your answer was negative, that means your values are decreasing. This area would have a negative rate of change because the temperature would be decreasing over time. That's about it.